The question is, how do we deal with pHs and pOHs when they're not whole numbers? Well, we used to have to use log tables and break things up into scientific notation and all. But right now, we're going to just use our calculators. Won't go back in history. So the question is, the pH of ammonia solution is 11.5, indeed, not a whole number. And we have to find the hydrogen ion concentration. Well, when we get hydrogen ion, if we have the hydrogen ion concentration, try and get the pH, we take the negative log, and we're just going to do the opposite here. We're going to go second function log. You can see the calculator says 10 raised to this power, and the power is going to be the pH, except it's got to be back to its negative value again. So I can put negative 11.5. If you forget that negative sign, you get a huge number. Don't forget, our hydrogen ion concentrations will be certainly less than 1. Well, let's see what our answer is going to be. Here it is, 3.12 times 10 to the negative 12. And if we're going to enter that into WebAssign, we would put in 3.12, and we would have to put E rather than times 10 to. And then that was a negative 12, and that makes sense because with a pH of 11.5, we'd expect to have a very, very low hydrogen ion concentration, and this is a concentration, so we're going to have to put in molar as part of our answer. So let me just move that here, and now as I can see, you've already calculated the pOH by subtracting, and we'll just use that same technique to get the hydroxide ion concentration. We can end up going the second function of log, which would be 10 to the negative 2.5 for an answer. But another way is, if you know the hydrogen ion concentration, you can find the hydroxide ion concentration by dividing it into 1 times 10 to the negative 14, because they both multiply out to that. So I'm going to do that method right now. I'm going to go 1, second function E, negative 14. These two concentrations always multiply out to make this. And I'm going to divide by my answer, which I'm going to get here, second function answer. And there we go. It's a higher concentration, and we'd expect that, our 0.00. And if you want 3 significant digits, 316. Technically, we should only have 2, but for WebAssign, we're going to need that. And don't forget to put down that it's molar. Now, I could have found that using the negative of the pOH. Let me do that right now. Second function, anti-log, negative 2.5. And we'll see if we get that same value. Okay, here we go. Live theater. And indeed we do. Okay, that's the answer.